So let me define the points. So this is O, this is S, this is Q, O, Q, C, okay, P is there, no? B, C, D, P, Q, R, R, S, T, this V, or I'll do one thing, I'll write P1, P2. It'll be much easier. Okay, now one more thing. What about the net flow of energy through OP1? Well, it depends on time. Yes, no, because you see that one. The antinode, it was having, now what happened, maximum potential energy, kinetic energy is zero here. No energy, here maximum energy. After some time, the energy here will become zero. Potential energy and kinetic energy will be, so there'll be flow of energy. So what happened to the energy flow in this region depends on time. Now only on the, what is the net flow of energy in the region OC? There's a string itself. So I'll put it, there's a string itself. Instead of asking, now I'm trying to compare this one in the region OP1. So shall I put like this dotted? Not only this, you can pick up all these regions. All that dotted regions, P3, P4, P5. What will happen to the net flow of energy through regions P1, P2, P3, P1, P3, P4, and P5? Depends on time. Will I agree? What happened to net flow of energy in the region O P1, P2, P3C? Means the one loop. Net flow of energy in one loop. What is one loop? One loop will become OBC. This one, there's a one loop. This one, shall I say, independent of time? It remains constant, no? That's what the standing wave. How much of energy then one loop should remain? It should remain fixed here. Net flow of energy in one loop through section OC, or you can say one loop OBC, independent of time. Independent of time or zero, because there's no net flow. Net flow of energy for OP4, OP1, P2, P3, P4, from section OP3, from O to P4, that one, there's everything. I think it should be non-zero. Dependent on time means as it will vary with the time. Here I say that it's a independent of time or remains constant. Here it varies with the time, because here maximum potential energy, kinetic energy is zero. Now energy will, as the string starts moving down, the energy of this will come here. So there'll be flow of energy. But what about the net flow of energy in the one loop? Zero, that one. How much of energy there will be confined there only. That's what I mean to say. Two things I just discussed here. So these are some types of questions what they can ask you here regarding the energy. You have to be careful. I'll go for totally out of this energy one. Just a theoretical questions is what they can ask you. How to calculate this maximum potential energy, kinetic energy? Already we know it, and that potential energy, kinetic energy of a string varies with the time. Okay, let me enter into the numerical part. Now, if we have two waves, There's only theoretical little bit difficult you may find regarding energy. So some okay, let's take the problem. So we have y1 is equal to a sine pi by 2 x minus omega t. In the region, I'll write it here. In the region x greater than 0, greater than or equal to 0, find the number of nodes in the region 6 meter. Okay, it can happen. So there'll be a fair difference, pi by 3 is there. So let's go for superposition of this. Y is equal to what we write, y1 plus y2. So this should become equal to a sine 2a sine pi x by 2 plus pi by 6 cos of, okay, this I just simplified. I'm getting this one. So we have to locate the position of nodes. So what are the nodes? The nodes are the points which will have zero displacement. For that, what I should have, pi x by 2 plus pi by 6 should be equal to how much? N pi. So let me x by 2 plus 1 by 6 equal to n, where n is equal to 1, 2, 3, 4. Just pure mathematics, nothing to do. So let's get the value of this one. X is equal to, it will be 2 if I take common. So 2n minus 1 by 3. Put n equal to 1, 2, 3, you'll get the location of the loads. So where are the loads located? Put n equal to 1. Now 1 should not happen, no? X greater than, they put n equal to 2. So 5 by 3, 11 by 3. Meter it will be. Next position 17 by 3. This will be the position of the nodes. He's asking how many are from 0 to 6 meter. I think 0 to 6 meter, where do will end up? I think this one only. So how many nodes are there? 3. You will get plenty of nodes, but he's asking the region x equal to 0 to 6 meter. So try to look at this one. This will have a phase. In theoretical discussion, we didn't brought. If the reflected wave is having some phase, no, then okay, the superposition, then again continue with the same mathematics. This will be very troublesome for you in exam. That's why I just picked up. Okay, fine. Okay, we'll take the next one. If the two waves undergo superposition such that their amplitudes are different, what do we get? If their amplitudes are different, so what has to be done? I'll give the situation. Y1 is equal to